Preston Van Loon. Excited to be here today in the middle of quarantine at my first ever Ethereal Summit. So this is really exciting for me. As you can see, we've been, you might have seen, we've been building Eth2, and we're really excited to talk about it. So let's just dive right in. I'm Preston Van Loon, co-founder of Prismatic Labs, career software engineer. You can find me online. My Twitter is Preston_Van Loon. I post a lot of things about our testnet that's going on and various updates on E2. So let's dive in. Who is Prismatic Labs? So we are an independent team of blockchain developers, software engineers, and we've self-organized at the beginning of 2018. So we saw a clear need for scaling of Ethereum, particularly in building it. The research was getting there, it was getting pretty close, and we became, we met online, Raul and I met online in the beginning of 2018, and we sort of have grown very organically since then. So we went from just Raul and I meeting for coffee one day to a team of 5 people moonlighting this kind of passion project. And today we are 8 people with over 75 contributors on GitHub. So that's really exciting as we build towards Eth2. So let's talk about just a quick recap of what we're working on here in phase 0. So I know you've heard recently in the last couple of talks a little bit about phase 0 and sort of the architecture of Ethereum 2.0. So in this picture, we have the ETH1 chain at the top layer. So this is there's a connection between the two. And then we have our beacon chain for phase 0 in this blue box, which is sort of the backbone of Eth2. Beyond that, in future phases, we're introducing shards and data execution. But in this talk, we're just going to summarize quickly the beacon chain and phase 0. So the beacon chain consists of primarily 4 key components. Most importantly, it is the validator registry, keeping track of all the validators in the set. To join this set, you conduct a one-way deposit on ETH1 through a deposit contract. The parameters to join, you need 32 ETH to initiate one validator key. So if you have less than 32 ETH, you will not be able to initiate a new validator. You can still send deposits as small as 1 ETH and sort of incrementally become a validator, but you will not be part of the active set until you reach that 32 ETH threshold. There's a ejection balance of 18 ETH, I believe. That's the recent number. So if you are suffering from a liveless leak or you go offline entirely and never come back, your balance will not diminish to 0. It will only diminish to 18 ETH before you're ejected. You can also exit voluntarily if you want. If you know you're going to be going offline for a long time, you can go ahead and exit and save yourself some penalty leaks there. The beacon chain also deals with calculating rewards and penalties, including slashing. It's important to note that a liveness and slashing are not the same thing. Slashing is an event that should never happen. It's only occurring through a gross misconfiguration of software, malicious activity. The beacon chain also deals with randomness through what's called a RANDAO. So this is really the biggest part of Eth2. It has a lot of components. It's what's taken the longest time. So as a validator, you're going to be given a slots in Eth2. We have slots instead of like a difficulty for block production, a block proposer at a particular slot. This is a less frequent event, and there are thousands or tens of thousands of validators. So the reward for proposing a block is slightly higher than being an attester, but everyone will be an attester at some point in epoch, depending on the parameters that depend on the committee that you're selected on. So a committee is a random subset of validators. So how do you become a validator? Well, it's not a very complicated process. There's just a few steps here. So first of all, you will send 32 ETH to the deposit contract. You can do that in one transaction or multiple, preferably just in one. That's the easiest way to do it. The nodes, the beacon nodes will see these deposit logs in ETH1, and they will go through a ETH1 voting round. So inside the state of ETH2, we're keeping track of the deposits and the latest eligible index for ETH1. So this has to reach a majority consensus before we can allow new deposits into the chain. This process is, or this voting round is 1,024 slots, so it takes a little while. And then once you have reached a finalized epoch, or once you've been eligible to get the deposit included and then reached a finalized epoch, then your validator will join the activation queue, and there is a minimum activation time of just over 2 hours. Once you've been moved through the queue, then you're active and can start immediately performing your duties. So proposing a beacon block, I won't go too into this. Basically, we're going to assemble all the components here. We have operations like deposits and slashings and voluntary exits, and in future phases we have transfers. We basically package this up, sign it, and then broadcast it to the network. This is kind of a quick processing. Don't really have a lot of time to go into it, but screenshot this if you like, and we can go over it offline. Attesting is sort of the same thing. The whole purpose here is that we are attesting to our view of the head of the chain, and this is exactly what we're using to reach finality. So this is a really important part of the system. A quick peek at the validator rewards and penalties. As I said before, proposing is slightly higher than a reward than attestations. Rewards and penalties are calculated every epoch, updated every epoch. The penalties will, for liveness penalties, will increase exponentially as we experience long periods of finality, and this is to discourage centralized providers and kind of get the chain back in a healthy state as soon as possible. So now we've got a little recap on ETH2. Let's dive into how do we go from research to implementation, specifically how is Prismatic Labs taking research and implementing it. So we really have just 3 core phases to this. The research phase, we're exploring new ideas, working with researchers online, in person, at conferences, or other online channels. We're proposing changes to the E2 specification. Terrence from our team is one of the #1 contributors to the E2 spec, so that's really cool. We also review changes from other researchers or implementation teams. And then finally, a spec release is tagged, and then we implement that release version on an incremental basis. So the implementation part is that we take the new changes and sort of digest them and figure out the most appropriate way to move forward. Taking a look at that feature lifecycle. For non-trivial issues, we'll put together what's called a design document, and this really outlines all of the trade-offs that we've considered in terms of adding a new feature. So if we see a really computational heavy method in the spec, we might want to cache this. So we'll talk about what type of caching mechanisms can we do. how can we perform better and save resources, and what are the alternatives. So we really spend a lot of time analyzing a feature and making sure we're moving in the right direction before actually implementing it. We use tracking issues to keep track of everything, so everything is really visible on GitHub. And then finally, once we've got approval within the team, everyone kind of agrees on what's going on, we'll start the implementation process. We spend a lot of time on code review, pull request code review. Everyone on the team's reviewing everything. We require at least one approval from someone to merge. And then we do a complex canary analysis, and then pre-prod soak testing. And then finally, we'll tag releases on a frequent basis for users in the testnet. Testing is probably the thing we consider the most important. It starts with unit tests. So every feature or every function that we're working on should start with a test, and we're making sure that we're covering every path that we can imagine. So sometimes there are edge cases you can't imagine, but that's where we get into other testing. We have specification tests, which are upstream tests from the Eth2.0 repo. These are kind of smoke tests or sanity checks that we conform to the happy path of the implementation. Sometimes we do mutation testing, which means to slightly change pieces of the code and assert that a test should fail. So if there was like a conditional branch that depended on some key parameter, if we set that to be always false, does some test fail? It kind of means that you maybe had coverage on that code, but you weren't actually testing what that code does. We also do fuzz testing, which is really important for us to catch unknown edge cases, particularly things that could crash the application. So this is really helpful for external inputs, unknown inputs, basically anything outside of our control. We want to make sure that's not going to cause issues with the client, so we're running those coverage-based fuzz testing. We also do end-to-end tests and integration tests. We run on every commit that goes to master. We stand up another testnet and run it for an hour and a half or 2 hours, basically just to make sure that the Genesis event still works, that the chain can run for a few finalized epochs, and that everything's working well. We do pre-production soak. What this means is that we're sending production traffic, so testnet validator traffic to new experimental features, and then comparing whether or not there was a regression there. So if there was more resources used or a higher failure rate, we're going to want to catch that before it goes out to release. All of this combined, you get peace of mind. You say, my code works and I can prove it. Look at all of these tests and nice things that we have. So testing is really, really important for us. Second to testing is monitoring. So we know that our code works at the code level, but how is it performing in real life? So this is a screenshot from the Topaz testnet taken this morning. We can get a quick look at our resource usage. At the finality rate, we have this like sawtooth time since finality, which is really great, really perfect. We have high healthy peer counts. Everything's working well. We're under 50% in terms of Prylab's network control, so that's really exciting that the network is majority community controlled. That's really cool. One thing that we pride ourselves a lot on is the pipeline for production. So we have invested a lot of time into infrastructure and really testing all of our new code before we tag releases. So for just about every commit that goes to master, we're going to run this big pipeline where we do a 3-hour canary test for regressions, and then finally deploy that to production, to our Topaz testnet. This has helped us since Sapphire keep the system alive and keep it from falling over. That was one of our biggest issues. We released a new feature and it breaks everything. And we've learned a lot since then and haven't broken production at all this year, as far as I know. So this has been really good. This is kind of what a canary test looks like. You can see here that this graph to human is kind of hard to read, but you get a nice summary on the left that says, look, this new version of Prism is actually using 5% more memory. So that might be something to look at. And that kind of really helps us understand how our code is improving over time rather than regressing over time. So these are really cool and important part of our infrastructure and feature set pipeline. So let's take a quick look at our roadmap so far, what's coming next. So we started this in 2018, and the first milestone we had was the Ruby milestone, where we wanted to release a proof of concept. This was Prism in its most primitive form on a very different looking specification in Q3 of 2018. It didn't do a lot of things like signature verification, but we could see that it was coming to life, that the core components of things were working. Since then, we've taken all the lessons learned from there and packaged it up into our next milestone, which was the Sapphire milestone. And this one has been probably our biggest achievement so far. We launched this, we were running this since April of last year, but the biggest restart of this was in January of this year. We had a coordinated Genesis event, which we had never done before. And we got a lot of feedback, a lot of engagement. We learned really quickly and iterated quickly. This ran for a couple of months before we were able to get up to the latest specification and relaunch a new testnet called Topaz. But before we get into Topaz, block explorers are one of the coolest things that came out of Sapphire. We rely on these tools a lot in ETH1 today, and it's great to see that already before Phase 0 launches, we have two amazing block explorers to choose from. We have Beacon Chain from Bitfly and the Beacon block explorer from Etherscan. So these are really awesome. Looking at Topaz, which is our latest milestone testnet release, this aligns to the 0.11 specification of ETH2. The difference between the mainnet scale of Sapphire and Topaz is that we're no longer using fractional deposits, so you actually need 32 test ETH to join. So this is very much like mainnet. We also have some new caching and new features enabled by default. So the client's been performing much better. We also have dynamic subscriptions, a lot of other fun things. And it's been actually catching slashable offenses in production. So that's kind of an exciting thing that is unique to Topaz, is that we're seeing slashable events and actually acting on them. What's next? So there's a coordinated testnet currently going right now. There will be multiple tests of this through coordinated Genesis events. We're working on promoting Prism to beta and getting ready for the V1 release. And then later this year, of course, there will be the Phase 0 mainnet launch. If you want to get involved, these are some helpful links. So we have our testnet onboarding portal, our documentation portal, the GitHub repository, and our Discord, and then we have our API. And as always, we're really happy to help. So if you're struggling with anything or just have questions, we are looking for feedback from anybody of any technical aptitude. All questions are great. All feedback is great. So reach out and we'd be happy to help. And we'll see you at mainnet. Thanks.